Again, thanks for a great crowd again. If you've been coming to the last two, we've been getting good crowds for this. So of course is part of our Deep Creek Lake Centennial Lecture Series, and we're trying to hit different aspects of the lake. Our first one was about wildlife and habitats in the lake. Second one dove deep into fish of Deep Creek Lake. And now we have representatives from the operator of the dam and power plant, Brookfield Renewable, to talk about how they work. So I'll pass it to Amy, and then she'll introduce Kevin. So, Amy.
Thank you. Thank you. Thank you all so much for coming. It's certainly an exciting time to be celebrating Deep Creek Lake's 100 year. Believe it or not, the majority of our hydros are 100 years or older. So it's certainly, we're not seeing hydros built these days. So it is something that we're used to. A lot of our assets are 100 years or greater. We have about 140 hydros across the United States, owned and operated by Brookfield Renewable, which was Brookfield Renewable US, and we have now recently rebranded. We are now Brookfield Renewable North America. The reason for that is because we have combined with our colleagues in Canada. So we do have assets in Canada now as well. We're all under the same umbrella. Besides the hydro, we do have wind, solar, and battery storage across the US as well. So that's a bit newer to our portfolio, but it is a different part of renewable energy that we manage as well. Kevin's gonna go through kind of a background of how hydro works. A bit detail about the Deep Creek facility. For myself, I'm the Senior Manager of Stakeholder Relations. I cover all of our U.S. operations, so from Maine to California. And I'll kick it off to Kevin.
Thanks. Yeah, I appreciate everybody coming out. So yeah, I'm Kevin Moriarty, Senior Operations Manager for Brookfield Renewable NA now. I oversee Deep Creek operation and maintenance. And I also oversee, so I got 6 hydros, 4 different states. So Pennsylvania, Maryland, West Virginia, and Minnesota. Have a brief presentation, and I'm gonna put somebody on the spot because he just showed up. But Mike Stemple is one of our Brookfield employees here at Deep Creek. So, we got just basically the hydro overview. So not going to get too deep into this, but there's all different kinds of hydros out there. This is a lake storage hydro. We have pump storage in our company. Pump storage is basically you're pumping water back from the river all the way up on top of a mountain into a storage, and then you release it and generate electricity. And then you have run-of-river. So most of my operations are run-of-river. Deep Creek was lake, and also where Amy's stationed at is Lake Wallenpaupack is a lake just like Deep Creek. So the higher water height equals a better efficiency. So it just varies on our basically what water supply we have at. So we have lake storage that we release down through some penstocks, or we just go straight down a river and through some turbines. Turbines spin and produces up electricity. So really not going to go through the principles. I'm going to get to the market. So the PJM market, so this area here is called the PJM market. And, did I go back? Let's see, happy clicker. I'm sorry. I'm looking at 2 screens. So Deep Creek Dam was constructed 1928, formed Deep Creek Lake. It produces electricity, 10 megawatts, 2 units, so a total of 20 megawatts. Roughly 1 megawatt will supply, we're pretty efficient nowadays at homes, but it used to be 250 homes. So the power market, how the power market worked, back in 1927, it was called Pennsylvania, New Jersey Interconnection. And then in 1928, Deep Creek Hydro was constructed by 1925, but the second hydro generator became commercial in 1928. And then in 1956, PJM officially forms in sorry, this is blurry. Official forms in addition of Baltimore Gas, Electric, GPU as members of the utility. 1993, PJM interconnection associates forms, and then the World Wide Web comes out. In 1997, it was a bid-based market, and this is where other companies, private-owned companies, could bid into the market. Prior to that, it was only utilities. In 1998, localized pricing, and then in 2000, auxiliary services became available. So Deep Creek is a running reserve plant, so it's spinning all the time. We're ready for the call. Whenever we get a call, they start up the unit and produce electricity. People that are sitting on standby, they're being paid to be ready for whatever time of day, change of weather, you know, hot days, cold nights. And then in 2001 is when Brookfield bought Deep Creek Hydro. So in 2022, if everybody remembers Winter Storm Elliott, this is where people are being paid to be ready for standby to start up their units. In Christmas of 22, the eastern part of the U.S. had sustained cold temperatures that resulted in a PAI event, which is basically PJM control center is calling to bring up all the units for the need for electricity because of the heat. And there were several utilities, several private-owned companies that weren't able to bring their units up, but they were being paid for standby. And so they got caught. And roughly about $1.8 billion worth of fines in 2022 for the people that did not, total fines, that weren't ready to come online. It was a pretty eye-wide-opening situation to where we have, in our company, we have procedures and policies to be prepared. We have pre-checks that all the plants do to make sure we're ready for the winter. We do this before the winter, just to be prepared to come up. If we're not able to run, we have to pull ourselves out of the market and say, hey, we can't run, and then we're not being paid reserve, and then when we're ready to go back in, we go back into the market. But we know how the system works, so we always make sure we're available those times of the years. So Deep Creek project description. Here's an overview of the dam and the powerhouse. You'll see the dam is over here to the right, Deep Creek Dam, and the blue line heading straight out towards 10 o'clock is the tunnel. And then where it curves and goes down towards the Youghiogheny at the very end is Deep Creek Lake. Oh, no, I'm sorry, Deep Creek Hydro. And that's where the powerhouse is at, where the two turbines and the technicians sit at. They're constantly working at both places, especially spring and summertime. We have a lot of grass to mow, and there's a lot of weed eating to take care of up there, maintain a nice dam, and allows the state to do an inspection for us. So every year we do an inspection with MDE, dam safety, and they're always wanting to look at the back side of the dam, front side of the dam, make sure there's no seepage. And we have weirs behind the dam that we're constantly monitoring for any seepage. If you start, it's an earthen bank dam, so you could have some seepage. It's a well-built dam, so we just continue to monitor it. A lot of PMs. We do preventive maintenance on there. The guys go out there and they take readings. We have piezometer holes throughout the dam. We're taking piezometer readings, checking the water level that could be in the dam for an uplift of the dam. And we're also doing inclinometer readings to make sure the dam's not shifted. If we do have an earthquake, we have policies in place where we're notified, the guys are notified to go out and do inspections. The control center, so we have a control center that will dispatch these guys to check for any damage, any cracking of the dam, so forth. So the Deep Creek Dam, located 1.4 miles upstream of the confluence of Deep Creek and the Youghiogheny River, impounds Deep Creek Lake, which covers 3,900 acres. The dam is an earthen bankment. Maximum height is 86 feet. The length is 1,300 feet. The crest is 2475. The emergency spillway is a concrete gravity. Primary weir is 720 feet long with a crest elevation of 2462. The secondary weir is 280 feet long with a crest elevation of 2452. I'm going to go to the next slide just so I can show you that, and I'll go back. So here's the dam, and then you'll see the spillway structure. That's the primary, and then there's a small concrete wall where it says emergency spillway. So if we ever get a high lake level, I think the last one was 1992, was a hurricane come up the East Coast, and they were working, I think they were working on a unit, had some problems going on, and the hurricane decided to take a sharp left turn into Maryland. So the only way to get water out of this lake is through our turbines, or we have a small minimum flow valve. That's only like 40 CFS that we can spill. So it crested, it spilled over the spillway, and it will puddle up where you see the water is, and then it will go over this emergency spillway, which will go down behind the dam and into the creek on the backside and go down to Mayhem and Road and filter back into the Youghiogheny. The water from Deep Creek Lake flows through concrete intake structure at the dam into 6,652 long concrete line tunnel, and then the surge tank that is 140 feet high, 30 feet in diameter. We'll have some pictures further down to show you what that looks like. From the surge tank, it has two penstocks, two steel penstocks, each 757 feet long and 6 feet in diameter that conveys the water to the powerhouse. So you'll have two steel penstock structures that goes down into the powerhouse. There'll be some isolation valves, and then they'll go into the turbine, spin the runner, which will spin the generator, and then the water exits into the tail race. There'll be some pictures later on that you can see on that. The powerhouse contains two power generator turbines, a total capacity of 20 megawatts. And each turbine passes approximately 300 CFS. So total output for water going through the powerhouse is 600 CFS if both units are running. The total length of the conveyance is 1.49 miles. So the blue, where it says penstock surge tank, that's the two penstocks going down. This is the powerhouse. It'll shoot through the bottom of the powerhouse, through the runners, through the turbine, spin the generator, and then it'll go into what we call a tail race where the blue starts, and then go out the Youghiogheny and takes a right and goes down the Youghiogheny River. One thing I'm going to talk about just a few slides up, but this is a pretty good picture, is you see where the blue line going towards the Youghiogheny, you'll see some concrete walls. Those concrete walls are weirs, and that was installed years ago by Penelec, which owned the company, owned the plant before Brookfield, and that's for dissolved oxygen. So the water will come up, will flow over there, mix up, get some air in there, and help raise the dissolved oxygen in the river, into the tail race, and put it into the river to help the fish out. This is a picture of the the surge tank. So the surge tank is connected to the top of the tunnel, and it's like a relief valve in your hot water heater. So whenever you overpressurize, that relief valve is going to release the water pressure out of there. So on hydro units, especially with a long tunnel like this, if you have a plant trip and your turbine inlet valves go closed, which is isolating the water from the turbine from keeping it spinning, if you had a problem, you got 600 CFS going through there and this thing goes closed, that water has to go somewhere. So they put surge tanks on top of these tunnels and the water will shoot up. And there's a standpipe in there, and it'll shoot up out of the standpipe and go back into the tank and filter back into the tunnel, and also water will backflow back out into the Deep Creek Lake. This here is Unit 1 turbine generator. This is the original generator skin, but we have had overhauls inside the turbine generator. So you'll have a generator is what is the big section, and this is on the generator floor. And then down, there'll be a long shaft going through the floor, and down below is enclosed runner. And then we have wicket gates that open up, allows water to hit that runner and spin to produce the electricity. This is one of our nicest, cleanest plants in the company. We have 2 technicians that work there full-time. They have complete ownership of this plant. They take great care of it. We just finished up an outage today, so we just do we do annual outages on both units. So Unit 1 was a 3-week outage. Basically, we're changing oils, we're taking readings on different things, cleaning, wiping up oil leaks, all kinds of maintenance that you can't do when the units are running. This is the time of year that we do this at Deep Creek, but other hydros in my area are different times of the year. It just depends on the need. We have a permitting process here that we start whitewater rafting next month, so we have to get everything done before that. So Unit 1 is always done in the spring, and then we'll hit Unit 2 in the fall when all our requirements are done. Let's see. So permit obligations, we have a permit that is issued by the state of Maryland, MDE. This is probably one of the only plants that we have a state permit. All our other plants are licensed by FERC, which is Federal Electrical Regulatory Commission. So the government issues a permit for all other plants, but here is a state ran, and we renewed that permit in 2020. It's a long process with all our stakeholders, so fisheries, whitewater, the lake, DEP, DNR. It's a long process. It takes quite a while. A lot of people involved in it. The new permit was issued in 2020, and there are a total of 24 requirements in this permit. So elevation is one of them. Elevation references the elevation is based on historic spillway dam 2462. That's top of the dam. New in 2020, the lake must reach an elevation of 2461 by May 1st, each calendar year. Competing interests with whitewater releases, which start next month. So right now, and there'll be a graph on here, right now we're in refill. I've heard there's been some talking that the lake is low. The lake actually is not low. We're right at our required upper rule band on our refill, and you'll see a graph on here how we'll just keep tracking that refill up until summertime. We'll have a month on there, and then we'll just level up for the summer. Rule band, the seasonal rule band is outline requirement 14, and provides the upper and lower elevations the hydro can operate within to meet the needs of the business and to turn a profit. All other obligations shall be balanced in the rule band as well. Excursions of the 0.3 above the upper rule band but below elevation 2461 shall not last more than 21 consecutive days. So we have a pretty strict rule band, and we're always collecting data on that. We send reports into the state of Maryland to show them that we're staying with our limits. But as you'll see, this rule band, probably a lot of you have seen these before, that we follow this rule band. So we have a water resource management team that is out of New York, and they have a model that they monitor lake levels, inflows, weather conditions, so forth. And they've done a great job with this rule band. We've had it since we bought the plant, and never had any any excursions where we were outside of it. The model permittee shall use a predictive model to manage lake levels. Proprietary model has been used successfully, operated for 23 years. That's the model I'm talking about. These water resource management will work with our local techs. Our local techs will notify them if weather conditions change. You know, they're up in New York, they're here. Sometimes you don't get correct data, but they do a fantastic job. So we do have dissolved oxygen. So the permittee shall have tail race weirs designed to increase dissolved oxygen levels. All project discharges above 5 ppm. So that was the weirs I was talking about earlier. We've also, since 2020, we've installed a dissolved oxygen system. The guys installed it. It's basically, we're putting air into the tail race. What happens in the summertime, dissolved oxygen goes low in the lake. And we're pulling, whenever we run, we're pulling water from the bottom of the lake, so it's causing the DO to drop in the Youghiogheny. So we're doing everything we can do to raise the DO up to a 5 and try to help out the DO in the Youghiogheny. It's been working pretty good. Been doing some tweaking for 2 years, 3 years, and every year is another challenge on these on DO, but we've always met our requirements at 5 ppm, but it's a lot of maintenance in the system. And so whitewater releases. The intent of whitewater releases is to enhance recreational whitewater enjoyment for the project tail race to Friendsville. Whitewater releases begin on Saturday after April 14th, which is a few weeks away, which is before May 1st elevation requirement of the 2461. These are competing obligations. So we have a schedule for the whole summer of whitewater releases. There's a set time. We don't pick that time, it's already set. And we'll do 2 a day, and we'll start the turbines up and put the water through there. We'll capture some generation. Depends what the market's is doing that day, but we're still producing electricity. And we'll put the 600 CFS into the river unless there's, it depends on what the CFS is coming down the river above Deep Creek. So we'll kind of blend in to try to get at least that 600 CFS or above for whitewater rafting. We work closely with Friendsville community. We have a website called Safe Waters that will has all the scheduling on there. Also give us run times, and also gives critical information on public safety. If we have some work going on somewhere, we'll put the information out on the website for everybody to get to. We use this website for all of Brookfield, so all the plants, you guys can go on there, you can look at different states, all the plants that we have, what features they have for recreation. We do a temperature enhancement. So during specific times of the year, water shall be released to prevent the Youghiogheny from reaching temperatures in excess of 25 degrees Celsius. Primary impact by the upstream water temperature and sun exposure. Minimal impact from the ambient air temperature at this time of the year. So we have a control center in Queensbury, New York. So the control center in Queensbury, New York runs probably 85% of our hydros in the U.S. Yeah, they'll start and stop it. So it's a control center, 4 desks, 40 plants on each desk. And that certain desk will have Deep Creek, and they have all the procedures. And they'll monitor temperature, they'll log into a system. We have a program set up, and they'll punch in the numbers, they'll give them what the temperature is, what it's going to be, and then if we need to bring the temperature up in the river, they'll go ahead and start the plant up. Usually 1 to 2 hour run time to get some cooler water into the river to bring that temperature down. That's a permit requirement, so it has to be done, and we haven't had no excursions on that either on missing those. Minimum flow releases. The permittee shall maintain and operate a bypass system at the project to maintain a minimum flow of 40 CFS. So the Youghiogheny has to have at least 40 CFS at all times or above. And, you know, summertime, you get in these droughts like we had this past year, the water gets low. So on your turbines, they have wicket gates, and we always have leakage in wicket gates, so that helps out the minimum flow requirement. But if we get down below 40 CFS, then our control center, along with our technicians, can open up a bypass valve on prior to the plant. You know, bypass the plant, put it in our tail race, and put it out into the Youghiogheny River to meet that requirement of 40 CFS. There's only 2 ways to get water out. Well, there's 3 ways to get water out of the lake. One way we don't like it is emergency spillway. The other way we like it going through the turbine. The third way, if needed, is the minimum flow piping to put the water in the Youghiogheny. So here's the lake operating rule ban. I know a lot of people in here are familiar with this. Right now, we're in March. And we're probably, I think today we were at 2458.5.6. So we are actually on the incline for May 1st to be at 2461 per our permit requirement. So we are on the high end of the rule band, and our control center, we're not generating because we're refilling. We could generate if we want for capture and generation, but right now things are kind of calmed down on the grid and everything, so we're focusing on refill to meet that requirement of 2461 May 1st. And then we'll keep that rule band at 2461 throughout the summer. We don't generate a lot during the summer because we have to keep that up by 2461 for the lake. If we get some heavy rain, you know, heavy inflows, we'll run, but let me back that up. We will generate if it's minimum flow requirement, temperature requirement. But for scheduled operation, it's if we want to go out and just put power on the grid just because that's not what we do in the summertime. We focus more on the minimum flow and the temperature enhancements. And then come July, August, we'll start focusing and pulling the lake down and just follow the rule band back down. The water resource team does an outstanding job on our model that we've used for 23 years. That's really it. Questions?
And I did put my contact information there. If you'd prefer to email me, I'm happy to take any questions you have, but please, any questions you have now, feel free to ask them, especially if they're technical. We've got Mike sitting right here, and he can answer them for you.
If you remember the show, Phone a Friend? That's it. Yes, sir.
Mark Brader here. Just a couple observations and comments, a few questions. First of all, you guys have been a good business partner to the lake.
Thank you.
And you do social media, and you put warnings about the lake flows and stuff like that. So that's acknowledged, and I appreciate that. Our family has been up there for about 70 years. So we've seen the lake go from a barren cogeneration lake that has gone to one of the Maryland's best resources as far as I'm concerned. So far, the lake is very, very pristine, and I think we all want to share the beautiful resources that we have.
Yes.
Deep Creek Lake is a misnomer. Average depth is only like 26 to 28 feet. It's a big body of water for man-made lake, but there's not a whole lot of water. And the question that I have is, I always notice that after July, it starts really dropping. And we live in the Kenyon Cove area, and once that starts dropping 6 inches to a foot, our beach goes out, 15 feet. And on we don't live on the coves,